Good day, everyone, and welcome. Those of you joining us on LinkedIn, it's fantastic to see all those Dagster users joining us, and for everyone on Zoom, welcome again. Today's session is going to be hosted by Vivi and Hazem, and it's titled How to Integrate Data Quality Checks into Dagster Pipelines. At Soda, our mission is to help data engineers like yourselves deliver trusted data products across your organization. Data products that people can rely on, that have the right quality data, good quality data. So whether you're working on pipelines in development or production or anywhere in between, we want to make sure that you have the confidence and you can rely on the data that will be used by the business to drive insights and make the right decisions. Today, we're getting technical, and we're going to see and experience how to integrate Soda data quality checks directly into the Dagster pipelines. I hope you'll get some great insights from this for those of you that are looking to get started with Soda or optimize what you're doing. Without further ado, and without any spoiler alerts, I'm going to hand you over to today's presenters, Vivi and Hazem, and ask them to introduce yourselves. Sit back and enjoy.
Thank you, Tash. Hi, everyone. Thanks for joining. So I'm Hazem. I'll be one of your presenters today, along with Vivi. We are both customer engineers at Soda and coming from a data background. And today we'll be showcasing two personas of a data engineer and a data analyst working together to define data quality in an organization. And so before we get into that, let's talk a little bit about what Soda is. So Soda is an end-to-end data platform, data quality platform that enables both business users and data engineers to collaborate and define data quality. And we do this by leveraging some key product capabilities, the first being data observability, where we monitor your data in production and by keeping track of some key data quality metrics over time, and then leveraging our time series anomaly detection algorithm in order to detect any irregularities with your data, be able to raise alerts to help debug those as fast as possible. Then moving down to the business checks, so this is where we enable business users to both self-serve data quality checks using our no-code tools, but as well collaborate on these data quality checks alongside their stakeholders of the organization using our Soda discussions. And finally, you can also leverage some AI assistance to help with writing these checks using Soda AI. Then moving back into pipeline testing. So this is where we move into the concept now shift left. And so where you test data as early as possible in your pipelines. Because the problem with the monitoring in production, so oftentimes when a problem happens, it is already in production, and then solving it can be quite tedious or costly. And so by employing pipeline testing and implementing circuit breakers throughout these pipelines, you're able to then cut off any bad quality data from entering your downstream assets. And then finally, here we have operational data quality, where Soda will provide you with the diagnostic information, both at the metric level, but also at the record level, into the specific records which have the data quality issues, which you can then route to the appropriate stakeholders so they can fix the problem at source. Then having a quick look here at how Soda fits into an existing ecosystem. So in the middle here, we have our SaaS offering. We are SOC 2 compliant. We offer single sign-on and role-based access management. And we leverage a component called the Soda agent to establish a secure connection to your data sources. Now, this is offered as part of our platform, but it is also managed on a Kubernetes architecture. And so if you're dealing with highly sensitive data or on-prem servers where you need to manage the networking there, you can actually also deploy this Soda agent within your own environment. Then move to the left here. So we connect to a variety of data warehouses, more modern ones like Databricks and Snowflake, but also legacy like Oracle and SQL servers, as well as data lakes, where with the data lakes, we leverage a connector such as Spark, Dask, or Pandas, as we load the data into data frames to leverage a compute as we don't actually extract any data into our system. Then in the orchestration buckets here, so this is where the pipeline testing and data contracts come to life. And so this is leveraging a component using called the Soda library, which is a Python library and command line interface where you can programmatically invoke your data quality checks throughout your pipelines. And then on the right now, we move into collaboration. So Soda will offer you out-of-the-box alerting system and an incident management service, where we also enable you to connect to your own workflows or services. So we have native integration, for example, with Slack and Teams. But you can also connect via webhook to incident management workflows in, for example, Jira or ServiceNow. And then for visualization and reporting, we also offer our own out-of-the-box capabilities for visualizations, as well as some metrics on your data quality and health. But oftentimes, people would have more, say, specific reporting requirements, guidelines, or standards. And so with this, we can enable you to actually, using our reporting layer, extract the reporting information from our API and bring this into your system where you can then build your own customized dashboards. And finally, we integrate with a variety of data catalogs where we can actually provide directly into your catalog the health or data quality status of your data assets. And so that when you are building a specific use case or using this catalog to look at your assets, you are able to directly consume this information on your data quality health. So now, without further ado, let's get into how to test data quality in a Dagster pipeline. First, let's talk about the business challenge, which is the successful operation of our Bikes for All company, which is a bikes company that has several stores across various regions and have been struggling a bit with keeping the data consistent and the reporting standard consistent across those regions. And so why we want to do this is that what we want to do is we want to ensure the accurate forecasts and make reliable reporting dashboards. And through this, we'll then be able to make enhanced targeted promotions, inventory placement, and more efficient decision making. And how we will do this is then by leveraging Soda to streamline our quality rules and standards across all of these regional stores, ensuring consistency also and reducing downstream impact. And so the agenda for the day, well, first, my colleague Vivi will be taking you through the role of an analyst, where you inspect the problem statement and the data quality issue in SodaCloud. You can add checks and create discussions in the user interface. And then we can move on to the more engineering side, where we look at how we can write Soda checks for data quality in different stages of our pipeline, how to invoke those checks, centralize them, review them in both Dagster and SodaCloud, and then finally, review our reporting results. Also in cloud, and for this example, I'll show a Power BI as well. So this, just to get a quick look here. So this is what our pipeline will look like, our workflow, where we start with some unstructured CSV file in our S3 bucket, and then we load those into data frames and run our first round of data quality checks on there before it is ingested into our Redshift warehouse. Once it's ingested into Redshift, we can then perform a reconciliation check to validate that the data that was ingested matches the data that is in the S3 bucket. And then we can perform our DBT transformations. And so these transformations will actually prepare the data to be consumed then by our data analysts or business users, who can then we can then externally trigger some data quality checks that they have defined using the self-serve no-code tools in the user interface. And then finally, we can review our results both in Power BI and in SodaCloud. And so now I'll pass it to my colleague Vivi, who will be walking us through the problem statement.
Thanks a lot, Hazem. So hello, everyone. I'm Vivi. I'm a data analyst in Bikes for All. And what we see here is a typical problem a business can face. I basically have a report where per quarter, I would like to see how my total sales go by brand. And this quarter, I actually have identified that there are negative sales in one of my brands. So let me quickly share my screen and show you how we can easily interact with SodaCloud, identify the problem, and then what we can do later on. Can you see my screen? Yes,
we can see.
Perfect. So what we see here is our organization in SodaCloud, and I can directly go under datasets and then filter here, as you can see on my data source on the left panel, for my Redshift warehouse, because I know this is our data source. Or it could be information that potentially comes out from the data catalog in the case my company is using one. I can scroll down and identify the data set that I have used to build this specific report. So I have found my data set, and then I see some basic KPIs on top, meaning how many checks I have around that and what is the current health status, meaning how many checks are passing over the total number of checks in the last 30 days. And then if I go under columns, I'm basically able to consume all of the profiling information that Soda makes available for me around my data. I can scroll down and I actually identify the problematical column of total sales. And already in the basic statistics, we see that there is a minimum of -1,000, which indicates a data quality problem. I can also further expand, and in the statistic analysis, I exactly verify this. And under the histogram, I actually see the distribution of this specific column, and I see that I have more than 200 entries that have a negative value. This should first of all be identified and also not occur again, because it's a major business problem in my use case. So what can I do from here? Scrolling up, I actually have the possibility to add a check from within Soda Cloud in a very easy and no-code way. When I click here, I see a guided UI wizard where I basically have some out-of-the-box checks that Soda offers, and it helps me set up a check in just a few clicks. What is available is checks around missing values, validity, numeric, duplicate, row count, freshness, schema, as well as I have the possibility of writing my own SQL query, or, for example, start a discussion with other stakeholders in the case and that I want to brainstorm around the check, or I don't know exactly how I should continue. In my use case, I would actually like to add a validity check to ensure that no negative sales occur in my data. Of course, I start by giving it a name. And then I have the possibility of adding a filter, which means that basically this check is going to be applied only in a specific segment of my data. So for example, in my use case, I could say I want this to specify in brand 1, but because I want this check to be applied in all of my data set, then I can omit this step for now. And of course, I also decide which is the column where I would like to apply the specific check. I continue by clicking under validity rule, and I see what Soda has to offer. So what I can do is that I can check for a valid or invalid format, a list of values, a regex, or even minimum or maximum. And this is what I would do in my use case, where I specify that the minimum value should be 0. And then below, I specify what is my notification level. And within Soda, there is a distinction between warning and failure. So I could say that I want 2 different thresholds, but in my specific use case, it's a very important rule. So I will keep it simple and say every time there is even a single record below 0, I should be notified, and then this check should fail. Last step is that we can add an attribute to the data set, and I can actually go ahead and do that. And what is an attribute? An attribute is basically a variable defined within Soda Cloud, and it works in 2 ways. The first thing is that it allows us to add extra information and metadata in our check. And the second thing is that we can use this attribute, or we can leverage this value as a filter for notifications or customizations and reporting. So in my case, I can say, okay, this is the data quality dimension of validity, and I would like to assign this to the team of data engineering. Scrolling a bit up, we see already that we have the scan definition pre-filled. And in this case, what does it mean? It's basically the schedule in which this check is going to be executed. But in my specific use case, I don't really want to schedule this check, but I would rather have this check be implemented or embedded in my data engineering pipelines. So instead of actually using the default scan and schedule this check, what I will going to do is I can basically select the triggering externally. And then depending on the permissions, I can either go ahead and add the check, or I can actually propose the check, which is going to open a new discussion. And then later on, the responsible person for this data source is going to be notified, and they can continue from here by reviewing and accepting the check. So Hazem, back to you.
Thank you, Vivi. Let me share my screen now. So now thank you, Vivi, for that. So now we've seen how to define and add checks to our SodaCloud account or organization. And now let's have a look at how this would look also in invoking it in a Dagster pipeline. And so coming back here real quick, just to have a look at our pipeline first, very similar to the diagram we have shown earlier. So here is where we will load in our files from S3, our CSV files, and run checks on those using data frames. And then here we can then perform our reconciliation check where we compare the source and target to make sure that that the data was ingested properly. And then here is where we have our two DBT models or transformations. And so these are actually this is where we execute the cloud UI checks that Vivi just defined. So this would be our business user checks, right? So the data that they are consuming, they are able to define the checks on top of that, which we can then execute dynamically in our pipeline. And then here we have some processing and reporting tasks, which with circuit breakers implemented should not execute. Now let's have a look at how this looks in code. And so, yeah, here we have our one of our assets. So we use an asset decorator. This is our first S3 asset, right? And so before we actually get into what do we do here with Soda and how we're using the Soda library, there's two essential components to running the Soda library or running Soda programmatically that I want to go to first, which are the configuration files and our check files. Both are written in YAML format. And so let's have a look here. For this example, is a configuration file. This is for Redshift, and the syntax here can differ slightly between one data source to another, but we have the full list and syntax available in our documentation. But so here is where you define your data source credentials, connection details, and you would be able to give your data source a name here. And then afterwards here, you can, in the SodaCloud part, you can then put your SodaCloud credentials, which will then push all the results of your running scans back into the cloud where you can then perform further analysis. Now to look at our checks file. So this is very easy readable YAML format. And so similar to how Vivi showed us in the no-code UI, we have our out-of-the-box checks, right? Row count here, freshness, but also validity and duplicates, etc. But we also allow for more unique checks where you can do change over time for specific metrics. And you can just specify thresholds, and you can specify timeframes where you track those changes. You can also use custom SQL to specify custom failed row queries, where you can get directly the failed rows of your failed checks. And then in the case, for example, that you have certain categorical variables that are interesting to subset by when performing the checks, you can also leverage a group by query that we have to be able to then subset such data before executing the checks on it. And you'll see here, I have a variable actually inputted. And so this is actually something that we can dynamically pass as part of our pipelines in order to be able to pass dynamic variables into our queries, essentially. And you see here, so similar to how my colleague Vivi showed in the no-code UI, we actually add attributes to all of our checks here to be able later then, to be able to filter and subset based on these tags, let's say. And finally here, just to show a quick example also. So here's an example of a reconciliation check, right? Where here you can specify your source data set and your target data set. So we see here our target data set was a data source that we defined, right? The Redshift data source. This data source here is not an actual data warehouse. So this is our CSV files that lie in S3. And we'll see how we create this data source when we go back to the code. And so here we can define some checks. We can do this at the metric level, at the schema level, but we can actually also write checks at the record level. So comparing specific columns with each other in order to validate them. So now let's have a look at the code. So now we leverage the Soda library to initiate the scan object, where then the first thing you can do is set a scan definition name. So, and then here you set the data source name. So this is, as I said, this is a data frame or data lake data source. So here I can just simply set the data source name. And then in this case here, I use a loop where I use the add pandas data frame on my scan object. And I dynamically read my files in the S3 bucket. Once that's done, you can see here, now I can add my configuration files and my SodaCL YAML check files, which I have just shown you previously. And here I can pass the dynamic variables. So here I pass a date and I can give it a date of my choosing that will be passed as part of the query when it executes. Now here I leverage something called the custom sampler. And so we'll have a look at what that actually does in a bit. But essentially, the custom sampler, so as I mentioned previously, we provide the diagnostic information at the record level, right? So you can have the failed row samples available in the SodaCloud UI. But I've actually opted to disable that and reroute these failed records back into my own environment, where I can then share these with the stakeholders in my organization. And finally, once our scan object is all set up, unstructured, configured, we can then use the execute method to run the scan. Now, to really make the best use of the Dagster integration, we made a little bit of a custom function here, leveraging the Soda API. And so let's have a look here. So what this does here is uses our API to collect then all the latest information on the checks that we have just run. So this is API is real time. So as soon as the checks run, it is updated in the API. So we then run the API, we retrieve all the results of the check using the checks endpoint with the dataset ID. And then I have some pretty simple logic here, depending on where I call it. But essentially, I use the asset check spec definition of Dagster to then make a list of the asset check specs, each one relating to a check that has been run in Soda. And so I append these in a list, and then I can pass them both at the beginning of defining the asset. So the asset knows these are the checks that are going to be executed later in the asset. And then once I run my check, I actually make the same call, and then I populate the results in my asset check result output. So similarly here, we can see in my reconciliation asset, we set our scan definition name, which is similar here, but here the data source is different, right? Because now we're using the target data set, which is on a Redshift warehouse. And then we add the config similarly again, which now has the Redshift credentials. And then I can also still add my data frames, which will then, I can specify that this is the Soda Dagster data source, which is the same one we defined earlier in our previous asset. And then the rest here is similar to what we have already seen. So I, again, employ the custom sampler, execute the check, and then we run this little custom script to get our check information, populate that into asset check spec list, which we can then get the results from. Now, finally, so here we run our DBT assets, right? Our two DBT transformation models. And then we have our UI check, right? So the check that VB defined and I trigger externally. So this is defined a little bit differently because this check actually applies to two assets. So in here, I use a multi-asset check, where in this case, also I refer to the check to be one single check, right? This UI check will be one singular check. And then you can specify the logic whether one single fail would make it the whole thing appear as fail in Dagster, or based on specific attributes, etc. But so here we actually use the trigger scan endpoint. So show here also what that looks like using some scripts. So we have our scan endpoint. We specify our scan definition here, and which is the default scan, right? And then we trigger the scan, we retrieve the scan ID in the response, and then we can use again the get scan status endpoint to retrieve the status of our scan. And so here I have also added some logic that waits until it's in a completed state. And then if there are any failures, it will return that there are failures. Or it will return, sorry, that the whole check has failed, rather. And so let's have a look at how this looks like back in Dagster. So if I zoom in a little bit here, so yeah, we can see here directly, you can see in each asset, you have the checks under it, which happens as soon as it materializes. And oops. And yeah, so when you click on the asset, you can see that right here. You can view all check details. You can see the history, right? You can see failing and passing checks. If we go to one of the checks here, so in the metadata, you'll find the cloud URL, which takes you directly into the SodaCloud, where you can then get the visualization, see some further patterns, and get more detailed results. And so here we see with the custom sampler comes to life. So here's normally where we would have your sample of failed rows that get sent to the SodaCloud. But since I opted for using this custom sampler, I get this message that the failed row samples are not stored in SodaCloud. And from here, I have an option to still retrieve the query, the failed rows query, which I can execute in my own environment to get those failed rows. But here also, I've decided to offer a customized link where actually it will take me directly to my environment, which has all the failed rows records saved, and then I can drill deeper from there. Similarly, the same thing can be done for our reconciliation check, right? So you have the checks that pass or fail here with the cloud URL and the metadata that can then again take you to the SodaCloud, and you can see the diagnostics of the metric, schema, and record level checks that are done there. And finally, we have our UI trigger checks, right? So these are the checks that were defined in our SodaCloud interface. And so you see here that we have, indeed, it is one check that just shows up as a failure. And so again, we have in the metadata, the cloud URL, which can take us directly to the SodaCloud, where we can actually see all the checks that were employed in this scan definitions. So I mentioned also that you can set up alerting mechanisms along inside the Soda. And so to see how that would look like here. So you see here we receive alerts for all our failed checks. And in this case, I set alerting for all of my checks. So all the checks that are failing, I'm receiving the alerts for here. And again, we have the view results button where it will take you to the SodaCloud, and you can look deeper also into the specific data set that has failed. So finally, we also have our dashboarding capabilities. Right? So this is where we can have our can see some metrics on the checks that failed, checks that warned, and an overall data health score of our data quality throughout the organization. And then some visualization here of your passing, failing, warning checks over the past 90 days. Now, if you have a lot of checks that are running or a lot of data sets in your organization, this graph can get quite noisy. So this is again where you can leverage these attributes to then be able to subset or filter these results based on the specific attribute that you are interested in. And so for example, here I can say that I'm interested in the checks that are related to the data engineering team, and we can apply that and get exactly what I need or exactly what I'm looking for. And so similarly, we also said that we can export using the API reporting layer, we can extract the reporting data and we can run this into our own environment. And so to show also an example of how this looks like here in Power BI, and so we can get our number of data sets or numbers checks, health score evolution over time, right? Overview of our data sets. And you can see here, we also leverage the attributes to create some charts. And if we drill through one of them here, we can get a status, our check status that is then filtered by the attributes that we are interested in. And so with just a glance actually you can really get an overall, very clear overall view of your data quality, health, and status throughout your organization. So we have seen then how to run data quality checks in the Dagster pipeline, and we will see then some key takeaways that that we have learned from this session. And so we've seen that, yeah, by testing early and often, you're able to catch issues before they propagate, and you can implement circuit breakers to then prevent your downstream assets from being contaminated. And then using our collaboration features or discussions, you can actually get feedback from your stakeholders, and you can be able to make your data quality in the standard that is expected by the consumers from the producers. And then finally, by automating this testing, right, you reduce manual efforts, your resources can go into more productive activities, and you can ensure consistency throughout various regions or stores, let's say. So thank you all for joining us on this session, and we'll be ready to take any questions.
Fantastic. Thank you, Hazem. Thank you, Vivi, for that great showcase. You can resume your normal roles now as customer engineers at Soda, arms down on being analysts and engineers. I know Matisse has been managing Q&A, and a few have come in. Matisse, can we hand over to you to present the questions for us, please?
Yes, sure. There is actually a question being asked right now. Whether it's possible to incorporate SODA testing as well in CI/CD pipelines. I have just, Jay, responded to your question as well. So yes, we do have integrations with CI/CD integrations like GitHub, and I have put the link in the answer so you can review them. Maybe one final question for you, Hazem. There was another one where it's about basically speaking about whether we so what if you want to run both no-code checks, right? So the one that are coming from more of the analyst persona, as we spoke about, as well as the more of the code-based checks coming from the data engineers. Whether is it possible to also run them within the same stage in your pipeline, or do they need to be in the different stages?
Yeah, that's a great question. So for sure, you can these can be both done at the same stage, right? So yeah, because one is done using the Soda library and the other is triggered using the API. So actually within the same asset, for sure that you can set up your scan configuration and then execute the scan, and then right afterwards also trigger your API defined checks in the UI. And so actually you can also, in this demo here, in this example, I've put all of my checks for different tables in one single asset, but you can actually have this separated. So each table would be its own asset, and you would then populate the appropriate checks of the appropriate asset directly in Dagster.
Cool. Thanks a lot, Hazem. These are all the questions. There was a final one I just answered into the chat. But no more questions here. So thank you for that.
Matisse, could I ask you, could you read out the question and answer just on the DBT? Sorry, I know that's a question that we get often, just in case somebody missed that in the Q&A panel as well. That would be fantastic.
Yes, no worries. So there was a question around what the advantages are of Soda in comparison with DBT, and then especially the DBT tests. So one of the main advantages of Soda is that we have a much broader scope of the different kind of check types, as Hazem shown, right? So we do not only cover the basics like DBT does, like missing, validity, freshness, schema, and so forth, but we also have much more complex check types like anomaly detection for a more automated way of thresholding, group by reconciliation to compare source and target, etc. Where as well with Soda, what we see from our customers is that with Soda, it's much more easier to test the quality of your data outside the scope of your transformation process that is managed by DBT. We do have, however, lots of customers which are using DBT in combination with Soda, where DBT obviously is used to manage more of the transformation process, and Soda leverage to verify the quality of your data. So in case you would already have existing DBT tests that you do not want to throw away, that's not a problem. We integrate with both DBT open source as well as DBT cloud to bring those tests in. Into Soda Cloud. They will look exactly the same as Hazem and Vivi have shown here today. So they will become a Soda check, where you can then also configure alerting on top of, so to be alerted directly in Teams or in Slack, and as well allowing you to keep track of the resolution of those the DBT tests via our incident management capabilities. So I hope that clarifies that question. If not, feel free to contact us.
Absolutely. I'm glad I got you to say that out loud. It's a great one. Thank you so much. Okay, everyone. That brings today's session to a close. We're there. We've made it through. Next steps for you, really clear. Join our community. Our Slack community is made up of our Soda team members, but also engineers and practitioners that are using Soda or getting started. There's tons of how-to best practices, lots of questions are answered there, and also a great place to find some resources and use cases as well. In addition, we have our docs, really comprehensive. They're known as one of our greatest assets that are out there. More use cases and assets provided by our customer engineering and technical team, as well as helping you get the best out of your Soda implementation and deployment. And when you are ready, our sales team are ready to support you on this journey. They can answer any questions with regards to commercial aspects of Soda, and also work with Vivi, Hazem, Arthur, Tyler, Eric, and Matisse to set up demos that are custom to your specific business requirements and needs. With that, I am left with nothing else to do but thank Vivi and Hazem for their excellent presentation. Matisse, thank you for managing the Q&A floor, and to all of you for joining us. It's been a pleasure. Thank you so much. That concludes today's session.
Thank you, everyone.